So what does a typical wind farm look like? You and I have an insatiable appetite for electricity. Come with me and we'll look at the issues relative to wind farms and the communities that they serve. This is the Windfarm Guy. Hi, this is Dennis Stout, and thank you for joining me for this episode of the Windfarm Guy. This episode will be the first part in a series on wind farm basics. Today, we're looking at what a passerby might see and a brief explanation of why it is that way. The components of a typical utility-scale wind farm are one or more rows of turbines perpendicular to the prevailing wind, with a distance between them of 2 or more rotor diameters. For instance, if the diameter of the rotor is 100 meters, the distance between turbines would be 200 meters if it's 2 rotor diameters, or 300 meters if it's 3 rotor diameters, and so on. Wind turbines do interact with each other, so the distance is necessary to avoid induced turbulences to the turbine rotor that can affect the life of the generator. The number of turbines installed depends on the chosen wind turbine model. An analysis is done of the wind resources to determine the wind turbine that would be the best fit for that location. An underground power collection system, normally around 20 to 30 kV, is designed to connect all the turbines. Sometimes an above-ground medium voltage power collection system is also used, although it happens very rarely due to the visual impact. Collection lines can only hold a certain amount of electricity. Therefore, the project will have multiple circuits, much like your home has multiple circuits to keep from overloading the equipment there. While the project is being designed, there is this internal battle between two types of engineers that are designing the project: the revenue guys and the expense guys. The wind engineers want greater electricity production, so they will put more space between the wind turbines, resulting in less negative interaction between the turbines. This would allow the project to make more electricity, therefore more money. However, the project managing engineers watching the budget want shorter cable lengths, so there is less cable cost and less energy losses. Saving money on the expense side also causes less production, which reduces money on the revenue side. There's a give and take here. In the end, they find a balance and move forward with the project. Other engineers design the project. Of course, they design the turbine foundations. They also design the small permanent lanes to the turbines, the temporary roads for construction, the crane pads at each turbine site, the substation, any transmission lines, the operations and maintenance facility, and more. All of the collection lines eventually go to the substation, where the main power transformer steps up the voltage to match the voltage of the transmission line that the project is tying into. From there, the power is taken to that point of interconnect via a small transmission line. The distance from the substation to that point of interconnect can vary greatly, and if the wind resource is sufficiently high, longer distances can be feasible. The interconnection point at the transmission line can sometimes be co-located with the project substation, where all the collection lines gather. In this case, which happens when the wind farm connects to an existing line or substation within the project footprint, there is no need for an overhead line at all. The permanent lanes going to the turbines themselves are small and typically a high-quality road. These are an expense, so wind companies build as few roads as possible. An operations and maintenance facility, known as the O&M, is built and used to store spare parts and has offices for the team that performs maintenance. It can also be integrated near the substation. If you like what I've said today, be sure and click like and subscribe below. If you have thoughts or want me to address a particular topic relative to wind farms, please also leave me a comment. Every wind farm, they're all specifically designed for that location. Next time, we will look at a closer look at certain aspects of wind farms. This is Dennis Stout, and I'm the Windfarm Guy. Thank you for watching. Working together, we can make good energy decisions and save our planet. I am the Windfarm Guy.